When you throw away a broken toaster, there is this inherent expectation of a magic trick.
Right, like a disappearing act.
Exactly. You drop it into a bin, the lid closes, and poof, it's just gone from your reality. You wipe your hands, the municipal truck rolls by the next morning, and you essentially have a completely clean slate.
It's a very comforting psychological illusion, honestly. We've built entire modern lifestyles around this idea that, away is an actual physical location.
Yeah.
Like it's a place where things simply cease to exist rather than what it really is, which is just a temporary relocation of our waste.
But when you actually step into the math of global consumption, that magic trick is completely ruined. We are thrilled to have you with us today because we are unpacking a fascinating university lecture deck on the circular economy.
And the underlying data driving these notes is, frankly, terrifying.
It really is.
We are looking at a planetary balance sheet that basically represents a mathematical dead end.
Okay, let's unpack this. What are the actual stakes we are dealing with here? I mean, structurally speaking.
Well, the stakes are the fundamental survival of our global climate targets. The lecture notes lay out the hard, uncompromising data that is driving this massive industrial shift.
The 2050 targets, right?
Exactly. If we intend to hit the global 1.5 degrees Celsius climate target by the year 2050, the structural changes required are staggering. Like, compared to 2019 baseline levels, the global economy needs to cut coal use by 95%.
Wow. 95%.
Yeah, and decrease oil consumption by 60% and reduce gas consumption by 45%.
Those numbers almost sound impossible when you think about the sheer scale of global manufacturing.
They do.
But here is the hook for you, listening right now. The immediate reaction to those numbers is usually, well, fine, we just need to build more solar panels, right? More wind turbines, and transition the energy grid.
Which is a huge misconception.
Completely. Because this deep dive isn't just about corporate sustainability or renewable energy, it's about rethinking the life cycle of every single physical object you interact with today. Because, as the sources definitively point out, we simply cannot meet these environmental targets just by swapping out our energy sources.
Right, the math unequivocally fails if we only focus on the energy transition.
Even if everything was powered by wind and solar.
Exactly. We have to radically change how we manage materials because the sheer volume of raw resources we extract, process into goods, and eventually discard, it requires an exorbitant amount of energy.
Regardless of whether that energy comes from a coal plant or a wind farm.
Right. Efficiency in our material usage is no longer optional. It is a structural prerequisite for hitting those 2050 targets.
So to understand the trap we're currently in, the lecture notes ground us in a really familiar mental model, the tragedy of the commons.
That's a classic.
Yeah, now, if you follow economics or business, you likely know the core concept. We're talking about human behavior and shared resources.
Right. To understand why we need a circular economy, we have to look at why we consume the way we do in the first place.
Exactly. So in the notes, they use this matrix of goods, excludable versus rivalrous.
Yeah, it's a great way to break it down. So picture a matrix. On one side, you have excludability, meaning can you stop someone from using this good?
Like a bouncer at a club.
Precisely. And on the other axis, you have rivalry, meaning if I consume this good, does it prevent you from consuming it?
So a slice of pizza is rivalrous. If I eat it,
Yeah.
you can't.
You got it. So this gives us four categories. You have public goods, like national defense.
Non-excludable and non-rivalrous. Everyone gets it. And me being protected doesn't make you less protected.
Right. Then you have private goods, like, say, jewelry. Highly excludable, highly rivalrous. Then club goods, like a private swimming pool. Excludable, but non-rivalrous up to its capacity.
Okay, so where does the tragedy of the commons come in?
That happens in the fourth category. Common goods. These are non-excludable, so anyone can access them, but they are rivalrous. The classic example is fish stocks in the open ocean.
Right, anyone can take a boat out and drop a net.
Exactly. But every fish I pull out of the water is a fish you can no longer catch.
And that leads to the tragedy.
It does. What's fascinating here is how clearly this classic economic theory explains the mechanics of our environmental degradation. In a system with a common good, individuals acting in their own logical, short-term self-interest will just overexploit the shared resource until it collapses.
Because if I don't catch the fish, someone else will.
Right. The structural trap is that the immediate financial profit goes entirely to the individual, while the cost of the degradation, the ruined ecosystem, is socialized. It's borne by everyone.
I want to map this directly onto our broader macroeconomic system, what the sources refer to as a linear economy, because it's essentially a straight one-way line to the local landfill.
take, make, consume waste.
Exactly. We extract finite resources, we manufacture a product, we consume it, and we trash it. But let me push back on this framework a bit here.
Sure.
If the environmental costs, say, the carbon emitted from shipping, the water polluted by textile dyeing, the loss of biodiversity, if all of that was actually priced into the goods at the register during that consume stage, wouldn't the linear economy theoretically correct itself?
You mean through pricing mechanisms?
Right. It feels like the issue isn't the straight line itself, but the fact that we've essentially weaponized the tragedy of the commons on a global scale by allowing companies to pollute for free.
That is the exact friction the lecture highlights. The Earth's biosphere is the ultimate unpriced common good.
Right.
The linear economy explicitly incentivizes businesses to extract raw materials and socialize the resulting environmental damage. You are entirely correct that if every negative externality were perfectly priced into a product, the market would shift dramatically.
A t-shirt would cost $100.
Easily. But practically, geopolitically, we have completely failed to do that. Therefore, the straight line of take, make, consume, waste remains mathematically unsustainable.
Because it assumes infinite cheap resources.
Exactly. On a decidedly finite planet.
Which means we have to artificially intervene to bend that straight line into a loop. Enter the circular economy.
Yes, the solution.
The sources provide a really robust definition from an expert named Esposito. A circular economy focuses on maximizing the benefits of everything that already exists.
It's total paradigm shift.
Yeah, it's about keeping materials in use at their highest utility across a product's entire life cycle, and then eventually converting the remaining unusable components back into a new source material for another purpose.
Going from waste management to resource management. And the lecture operationalizes this transition through three fundamental strategies.
Slow, narrow, and close.
Right. To escape the linear trap, industries must slow, narrow, and close their resource loops.
So let's dissect the actual business mechanics of these three pillars. Let's start with slow.
Slowing a resource loop simply means extending the life of a product.
Right, so if a jacket lasts 10 years instead of 2, it drastically delays the need to extract new cotton or petroleum to replace it.
The notes actually use the example of designing a higher quality t-shirt that can survive dozens of washes without falling apart.
But let's look at a real-world business case for this because I struggle with the financial logic here. Think about Patagonia's Worn Wear program.
Oh, that's a great example.
They actively repair their customers' old gear. But as a business model, repairing the jacket I already own actively cannibalizes your opportunity to sell me a brand new one.
Yes, it does.
So how does a massive company justify slowing the loop to its shareholders when it threatens immediate sales volume?
Well, it requires a completely different valuation model. You are trading a short-term transactional sale for long-term customer lifetime value.
Oh, interesting.
Yeah, Patagonia's willingness to cannibalize their own new product sales builds a level of brand loyalty that allows them to command a significant price premium up front.
Right, because I know I'm buying it for life.
Exactly. They aren't just selling a jacket, they are selling a durable asset with the service attached. But you're right to point out the friction. For a fast fashion company built on rapid turnover and razor-thin margins, slowing the loop is an existential threat to their entire business model.
Okay, here's where it gets really interesting. Let's move to the second strategy, which is narrowing resource flows.
This is all about resource efficiency during the production phase.
Be using fewer inputs per product.
Right. If a textile factory adopts a water-saving dyeing technology or uses an organic cotton that requires fewer synthetic chemical inputs, their operational overhead drops.
The notes actually cite Toyota's lean manufacturing system for this, rooting out physical waste on the factory floor, optimizing logistics, reducing energy use.
Which proves that narrowing is often the easiest pillar for traditional businesses to adopt.
Because it aligns perfectly with cost reduction incentives. This proves that efficiency isn't just some eco buzzword, it is classic, ruthless business optimization. Being green here literally translates to saving green.
Yes, exactly.
Yeah.
Lean manufacturing relies on continuous feedback loops to identify and eliminate non-value-adding processes. However, efficiency has a ceiling.
Right.
You can optimize a factory to be incredibly lean, but eventually the product leaves the facility, gets used, and wears out.
Which brings us to the third and arguably most difficult strategy, closing resource loops.
Recycling and stimulating material reuse so that nothing ever actually becomes waste.
Right, so if we go back to our t-shirt example, Closing the loop could mean mechanically downcycling the worn-out fabric into industrial cleaning rags
Hmm.
or housing insulation.
Or if you've designed a fully biodegradable organic cotton shirt, you can literally compost it.
Oh, wow. Just put it in the dirt.
Yeah. It breaks down, produces biogas, and the nutrients return to the soil to grow new cotton.
Okay, I want the listener to mentally apply slow, narrow, and close to the clothes in their closet right now, or
Yeah.
even the smartphone in their pocket. Because you just mentioned composting a shirt, which is amazing, but
That works beautifully for biological nutrients.
right.
But the complexity skyrockets when we talk about technical
It's
nutrients.
a smartphone.
Exactly. The notes outline the life cycle of a laptop. Closing the loop here means a company like Dell recovering the metals, the rare earth elements, and plastics from non-reusable parts of old computers to manufacture new ones.
Which is incredibly hard. This isn't just dropping an aluminum pan in a blue bin. It is essentially urban mining.
It's exactly urban mining.
And the friction there is immense. If you think about modern electronics, they are glued together, they're soldered, they're designed to be as thin and proprietary as possible.
Yet planned obsolescence or just designed for aesthetics.
Right. So the energy and labor required to chemically separate the rare earth metals from a fried motherboard just to close the loop seems like an absolute nightmare in terms of reverse logistics.
It is a massive hurdle, and this is why the three strategies are interdependent. You cannot effectively close a loop if you haven't first narrow the complexity of your materials and design the product with end-of-life disassembly in mind.
You have to plan the death of the product before you even build it.
Exactly.
So let's zoom out from the individual products for a moment. We've talked about jackets and laptops, but how does this scale up to entire macroeconomic systems? Transitioning a whole nation from linear to circular requires widespread technological innovation,
At a macro level, it necessitates a structural reorganization of society.
meaning there will be winners and losers.
Absolutely. Certain established linear sectors will inevitably face systemic decline, while new circular sectors must rapidly scale up to replace them. The lecture provides clear roadmaps for this.
Like what?
Well, in the energy sector, obviously, a massive pivot toward renewables.
Yeah.
In mobility, it means fewer individual combustion engines and a heavy reliance on EVs, expanded public transit networks, and integrated car-sharing platforms.
They mention mobility, the car-sharing platform, in the notes, right?
Yes. And in the food sector, it demands a systemic reduction of agricultural and consumer waste.
And in the building sector, which is notoriously resource-heavy, it means reusing existing materials rather than constantly mining new sand, gravel, and ore.
The notes highlight a Swiss company called Circulit as a prime example of this.
Right, they're innovating in circular concrete construction.
Yeah, making concrete out of recycled materials.
But this actually brings us to a fascinating macroeconomic measurement problem. Let's talk about the Swiss paradox.
Oh, this is crucial. The OECD material productivity chart.
Yes, because there is a chart in these sources that completely upended my understanding of national sustainability.
It's a vital piece of context.
So for the listener, this graph measures material productivity, which is defined as the amount of economic output or financial value generated per unit of physical materials consumed by a country.
Basically, how much GDP does a nation generate per ton of stuff it uses?
Exactly. And in 2022, Switzerland is sitting pretty at number 1, miles ahead of the OECD average.
They look incredible on paper.
Looking at this chart, you would assume Switzerland has solved the puzzle. Like they are the ultimate frictionless model for the global circular economy.
But if we connect this to the bigger picture, that top ranking is largely a statistical mirage.
Wait, really? A mirage?
Yes. The lecture notes explicitly pull back the curtain on this metric. Domestically, within its own borders, Switzerland's economy looks incredibly dematerialized and efficient. But the catch is what they import.
Ah, the imports.
Right. The CO2 emissions associated with the products Switzerland imports from abroad are more than 3 times higher than the emissions generated domestically.
See, this gets me fired up because this is just geographical accounting trickery.
It really is.
If a highly developed country simply outsources its dirty, linear manufacturing to other nations, say, shutting down local steel mills but then importing millions of tons of steel from factories in emerging markets with lower environmental standards.
And then just imports the finished, high-value goods.
Exactly. Then material productivity becomes a highly deceptive metric. It completely obscures the true global footprint of that economy. It gives the illusion that you've successfully narrowed your resource flows, But in reality, you've just pushed the toxic waste and the carbon emissions out of the camera frame.
Out of sight, out of mind. It perfectly illustrates why macroeconomic metrics can be dangerously misleading if they fail to account for the entire globalized supply chain.
You can't just look at one country in a vacuum.
No, you cannot claim circularity if your efficiency relies on linear extraction occurring in another hemisphere.
So what does this all mean for actually solving the problem? I mean, if national statistics are this easily manipulated, the meaningful, undeniable groundwork really has to happen at the micro level.
Inside the operational guts of individual companies.
Yes, the sources outline 7 stages of waste minimization that a business must undergo to achieve true circularity. But looking through these, it reads less like a simple checklist and more like an operational gauntlet.
Oh, it is absolutely a gauntlet.
Let's talk about the sheer friction of executing this.
It requires implementing slow, narrow, and close across every single departmental silo. Let's start at the front end. Procurement and product design.
Okay.
The lecture states a circular company must actively source used production inputs or upcycled materials and design products specifically for repair and eventual disassembly.
But think about the supply chain reality of procurement. Like, if I am a manufacturer making millions of office chairs, I can't just hope there's enough recycled, high-grade aluminum available in the secondary market this month to meet my quotas.
No, you need guarantees.
Right. The market for virgin raw materials is subsidized, it's highly predictable, and it's massive. The supply chain for upcycled materials is currently fragmented and volatile. How does a chief operating officer justify relying on a volatile secondary market?
Well, they often can't, unless they form long-term, closed-loop contracts with their own suppliers, essentially creating a private circular ecosystem.
Which takes years to build.
Exactly. Which brings us to the middle stages, internal production and logistics. This is where companies must reduce water and energy consumption, but crucially, optimize their delivery routes and internal storage.
And this is where we hit the reverse logistics paradox we touched on earlier with the Dell laptops.
Right.
If you design that office chair to be disassembled, you still have to physically transport that broken chair back from the consumer's home to your facility at the end of its life.
Yes, the collection phase.
Are we seriously arguing that dispatching diesel delivery trucks across the country to pick up empty, broken chairs is a net positive for the environment? The carbon footprint of returning the physical good often threatens to completely negate the environmental benefit of recycling the material in the first place.
It's a huge issue, which forces companies to entirely rethink their geographic footprint.
How so?
Well, you can't have one centralized megafactory anymore. Circular logistics often require decentralized, localized micro-hubs for repair and disassembly to minimize transport emissions.
Oh, so instead of one big factory in one state, you have 100 small repair hubs across the country.
Exactly. But the most radical friction occurs in the final stages: marketing, sales, and after-sales.
Yeah, as consumers, we usually only see stages 5 through 7 anyway.
Right. And the lecture emphasizes a massive paradigm shift here, moving away from selling objects entirely and transitioning to products as a service, or PaaS.
Leasing, expanding rental models.
Exactly.
So instead of selling a consumer a washing machine that they eventually throw away, the company leases the service of washing clothes. The company retains permanent ownership of the physical machine.
Which completely flips the incentives.
I see the environmental logic. It gives the manufacturer a massive financial incentive to build the machine to last 20 years, effectively slowing the loop, because they don't want to keep repairing their own machines.
Right. Planned obsolescence becomes a liability instead of a revenue driver.
But financially, the cash flow implications for a traditional business making this pivot are brutal. You are asking a company to forfeit a large lump sum of revenue today in exchange for pennies dripped out over a decade.
It requires a total restructuring of corporate finance. Wall Street values rapid quarterly growth, and products as a service inherently smooths and delays revenue.
They hate that.
They do. Furthermore, retaining ownership means the company is now responsible for the final 7th stage, end of life.
Because it's still their machine.
Right. They have to manage the upcycling, the refunds on returns, and the material recovery. It is a rigorous, holistic transformation. A company isn't truly circular just because they use a biodegradable shipping envelope.
Exactly. So what does this all mean? It means they have to rethink their core existence, from the financial models in the boardroom to the exact routes their delivery trucks take.
It's a systemic overhaul.
We have covered some incredibly dense ground today. We started by exploring how human nature and the tragedy of the commons traps us in a linear take, make, waste economy that is mathematically doomed by 2050.
Unquestionably doomed.
We unpacked the three essential strategies to escape it: slowing, narrowing, and closing resource loops, and the severe operational friction companies face in doing so.
Yeah.
We looked at the danger of deceptive macrometrics, like the Swiss paradox, where a nation looks green but is actually just outsourcing its carbon footprint. And we just explored the immense logistical and financial gauntlet of corporate circularity through those 7 stages.
It is a really complex transition, but understanding the mechanics behind it is essential for navigating the modern economy.
Absolutely.
And, I'd like to leave you with a final thought to mull over, one that builds directly on that Swiss paradox we discussed.
Oh, please do.
We saw how easily a nation can accidentally greenwash its own statistics by outsourcing its dirty production to other countries. I think it is deeply important to ask, how often do we do the exact same thing in our personal lives?
Wait, that's a fascinating pivot. What do you mean by personal outsourcing?
Think about the physical act of recycling. When you throw a perfectly good, but perhaps slightly outdated item into a recycling bin, you get a little psychological dopamine hit.
You feel like you did a good deed.
Exactly. You feel a false sense of ecological accomplishment. You did the right thing. But in doing so, you are completely ignoring the invisible massive amounts of energy it takes, a fleet of trucks to transport that item, the industrial heat required to melt it down, and the resources needed to remake that material into something else.
Wow, we're just washing our hands of it.
Yes. We often use the recycling bin to outsource our consumer guilt, just like a country outsources its carbon emissions. The ultimate circular strategy, the absolute most effective way to narrow a resource flow, might just be looking at the item in your hand and asking if you really need to buy it in the first place.
That is heavy. Next time you drop something in a bin and wait for the magic trick to happen, remember, away is not an actual place. The loop always closes, eventually. Thank you for joining us on this deep dive. Go out and look at your world and the objects you use a little differently today.